Hello, everyone. In today's video, we're going to talk about how to write a reusable step-by-step protocol. So before we start, I think it's important to clarify what types of protocols we're going to focus on in today's video. So for the purpose of this video, we're talking about reusable step-by-step protocols. And these are protocols that specify how to complete a research procedure by outlining a chronological set of step-by-step instructions. We know that some fields use the word protocol very differently, and so I want to start by clarifying that we are not going to talk about study design protocols, pre-registrations, or clinical study protocols. The reason for this is that these types of protocols are formatted quite differently. They contain a lot of information that's important for evaluating the design and the quality of a study, but is less likely to be reused by others. For example, a clinical study protocol may talk about how participants were identified and recruited and inclusion and exclusion criteria. However, there is one caveat here, and that is that study design protocols and clinical study protocols may contain reusable step-by-step protocols for performing specific procedures. So perhaps how you did a particular measurement in your study participants or how you implemented an intervention in a clinical trial. And the contents of this video would apply to any reusable step-by-step protocols that you have within your study design protocol, pre-registration, or your clinical study protocol. So I'd like to start out by thinking about why we should deposit reusable step-by-step protocols. Why are protocols so important? There are a few different reasons for this, but we'll start off with the idea that protocols and methods are one of the most reusable and useful outputs that researchers create. So when we listen to the open science movement, there is a lot of emphasis on sharing our data, on sharing our code, on sharing our publications by making them open access. And that means that protocols and methods are often overlooked. And this is a problem because of all of the things that we produce, our methods and our protocols are one of the things that others can most easily reuse and are most likely to want to reuse in the context of their own work to build on our research. So when we're implementing a method, reusable step-by-step protocols are often much more useful than the general text descriptions that we find in the method sections of papers. And I'll show an example of this later. The second important thing to keep in mind is that we can't reuse open data responsibly if we don't understand how these data were generated. And this includes the strengths and limitations of the study designs and the methodological techniques that were used. So data without any information about how they were collected aren't valuable for reuse to others in the scientific community, or are likely to be misused in ways that are not appropriate. And that's one of the reasons why it's so important to think about sharing our methods and our step-by-step reusable study protocols. When you are depositing protocols in a protocol repository, this is also a practice that benefits you. It's not just for the good of science. And there are a few ways that this can benefit you. The first is that it helps to ensure that everyone on your research team is using the same procedures. So if you don't have protocols written down, or if people aren't using those protocols when they're conducting their experiments, you may find that there's drift in the protocol, and different people are doing things differently, which can lead to different results. It also allows you to track changes as the protocol evolves. So those of us who work with methods and with protocols all know that the question is not whether your protocol will evolve, it's when. There are always going to be changes. It may be because you get a new machine, the old machine is no longer working. Perhaps you had to change reagents because a reagent is no longer sold or has been discontinued. Perhaps you adapt your protocol to apply the method to a new circumstance, a new type of sample. You may have a computational pipeline that you are wanting to do on a new data type or with a new software program. All of these are things that having protocols deposited in a repository can help us to track and understand the changes in that protocol as it evolves over time. The next reason is it's important to determine what version of a protocol was used for a particular experiment or publication. So as your protocol evolves, you're going to be having different versions of that protocol. And we want to know which version was used for that experiment or publication. And if you have your different versions of your protocol on a repository, then you can simply cite the version that was used for a particular study. And when you go back to that study 5 or 10 years later, you'll be able to tell what version of the protocol you were using at the time. The other nice thing about protocols on repositories is that repositories provide long-term access to protocols, even if you haven't used the protocols in years. Maybe you're going back to a new technique, or maybe you're going back to an old technique that you haven't been using in a while in your active research. Or maybe the person who is responsible for the protocol has left the lab and you've lost the documentation for what they were doing. Well, if those documents are on a public repository, it's not a problem because everyone still has access. Or you yourself might move to another lab or research group or institution. And if your protocols are on a public repository, you still have access to what you were doing in your prior research group. The next thing is that having well-documented and up-to-date protocols can accelerate the training of new team members. So when we bring two new people on, often they may get a partially documented protocol, or perhaps they simply learn by watching what we do in the lab. Having a very well-documented and clearly explained protocol makes it easy for that person to follow the instructions, to learn as much as they can on their own, and to make sure that they are following and going through all of the steps and understanding things each time they implement that protocol throughout their learning process. And lastly, others can cite and use your protocol, and this can help you to establish collaborations with others who are building on your methods. What makes a protocol useful and easy for others to follow? Well, I would encourage people to pause the video that you're watching now and take a look at this other video that I'll link in the comments. And it's an example using something familiar. So in this case, it's an example of written protocols for how to write a peanut butter and jelly sandwich. And as you're watching this video, I want you to think about what information you might need to reproduce a protocol that you've never seen before, or that you've never done before, which can be quite challenging. So including elements like very detailed instructions, making sure that there's no missing information and you're capturing unwritten knowledge, having short video segments and photos can help future lab members and others outside your research group to implement your protocol. And reusable step-by-step protocols save everyone time. Here's an example, again, using something that we're familiar with, and this is created by my colleague, Renee Bernard. And so here we have a creme brulee protocol. On the right-hand side of the screen, you will see a step-by-step protocol with pictures, with detailed instructions for each piece. And on the left side of the screen, you'll see the description that we might find in a study methods section. And so this is a general text description. It says the contents of 1 vanilla bean was added to a sugared heavy whipping cream solution, 400 milliliters, which was briefly heated and stirred into 5 to 7 egg yolks, from which residues were subsequently removed before adding 80 milliliters of the final solution into 8 100 milliliter glass dishes. Dishes were heated to 91 degrees Celsius using a standard household oven until the surface was firm. Dishes were allowed to cool down before being caramelized by adding white sugar to cover the surface and melting using a small blowtorch. And so if we were to compare the protocol with the general text description in the methods section, we would see that there's a lot of information missing from the methods section and that the protocol is much more user-friendly. And so if we had to make this recipe or implement this protocol, we would probably want the step-by-step protocol as opposed to the general text description that we find in the methods section. So how do we write step-by-step protocols that others can reuse? You want to think of your protocol as a modular self-contained publication that provides all the information that someone would need to evaluate whether this protocol is useful for them and meets their needs, and then to go ahead and implement the protocol in their own research context. Here's some examples of sections that you should have in your protocol. Obviously, we need a title that clearly describes what the protocol is about and gives people a clear understanding of whether this protocol is interesting for them. You want to list the authors or contributors to contributed to the development of the protocol. Sometimes the people who are sharing the protocol aren't the people who developed the protocol. And this is often the case with protocols held by research groups where the methods have evolved over time. And perhaps it's been forgotten who it was who originally made that protocol. So if you are a person who's depositing, but you aren't necessarily responsible for developing the protocol, you want to make that clear as you deposit the protocol on the repository. Your protocol will need an abstract, a list of items required to complete the protocol, including equipment, chronological step-by-step instructions, troubleshooting information, expertise, safety information, limitations and assumptions, as well as references. Let's go into a little bit more detail about what you might want to include in some of these sections. So for the abstract, you want to clearly specify what the protocol produces. And again, this is to help someone quickly determine whether the protocol is potentially useful for their research needs. Next, we have a statement of expertise. So whenever we're implementing a protocol, it's really helpful to know what knowledge, expertise, or training someone might need to implement the protocol. And that may include a criteria for how you know when your training is good enough that you can actually start using that protocol for research purposes. And again, this gives people a clear idea of, is this protocol appropriate for me? Is it something that I can use? What might I need to invest in training myself in order to be able to use this protocol? The next thing is safety information. So if there are any safety warnings relevant to the research that you're conducting and the specific protocol, you want to make people aware of those things so that they are cognizant of that as they are starting to work on implementing the protocol. The next piece is limitations and assumptions. So you might want to describe limitations or assumptions underlying the protocol. So perhaps the protocol doesn't work with a particular sample type. It's designed for a different sample type. Maybe there's an assumption in your measurement. Perhaps you have to assume some type of equation or a particular value of a constant. Whatever it is, it's important to let people know about those assumptions underlying the protocol and how they influence the results. And lastly, references. As with a paper, we often cite references with a protocol. And there are many reasons why you might cite a reference. Perhaps you have a reference describing materials or organisms or equipment or software that was used in developing your protocol, maybe even a questionnaire or a survey. You might have references of papers that have used the protocol to generate data. Or you might want to cite other protocols that were used to develop the current protocol. So maybe you borrowed a few steps from an established protocol and you want to cite that protocol to give those authors credit for their work. The list of required items. This is a really important thing. It's like an ingredients list for a recipe. It tells us what we need to complete the protocol. So there are a number of things to keep in mind when you're preparing this list. The first thing is you want to clearly specify what materials are needed to perform the methods. And this includes not only materials, but also equipment, perhaps model organisms, software, anything that you need to do this particular method. It's helpful for readers, especially if you have a long list, if you subdivide that list into sections according to item type. So for example, reagents, solutions, material, equipment, biological samples or organisms, software, surveys, whatever it is that you're using for your particular research application. And that, again, makes it very easy for people to find what particular categories of things they might need, and also helps them if they need to order supplies or source equipment. We want to use RRIDs, or research resource identifiers, in order to identify cell lines, antibodies, plasmids, model organisms, software and tools, and core facilities that are used in implementing our protocol. RRIDs are unique persistent identifiers for research items. So it's kind of like a DOI, except for research things. You can look up RRIDs using the RRID portal, and you can also use the portal to create new RRIDs for things that don't have an RRID yet. And so I would encourage you to watch our video about RRIDs to learn more about how to use these in your list of required items. The next thing is that you want to specify vendor information when it's relevant, or other key identifying information. So for example, the software version number or the lot number for a polyclonal antibody. If you need solutions, then you want to provide details. So for example, the recipe, the ingredients, and the concentrations. And you should also provide details on any biological material that you're using, for example, the species of origin, the concentration, density, and dilution, or the stability of material, for example, acceptable numbers of passages if you're working with cell lines. And what exactly you need to provide in this section will again depend on the type of research that you're doing. The chronological step-by-step instructions are the main section of your protocol. This is where you're going to spend most of your time. So when you're writing this step-by-step set of instructions, you want to have single-step instructions. So one instruction per line that someone could easily follow. You want to use active voice, and we'll talk more about that in a minute. You want to provide very detailed instructions that would allow someone else to implement the protocol. So for example, you might include times, volumes, temperatures, centrifugation speeds, or whatever other details are relevant for the particular type of research that you're conducting. And if you specify a range of values instead of giving an exact number, then you want to explicitly state what factors influence which values one should select. So for example, use values at the lower end of the range in this situation and the higher end of the range in this other situation. You want to identify especially important or critical steps and specify the expected outcomes for each of these critical steps. So perhaps you say the solution should turn blue if this step has worked. If you're working with a protocol that has timing, you want to specify the amount of time that's needed for each step. And this helps others to actually run the protocol in their own research environment. You want to give instructions on how to interpret the data if your protocol is generating data. And you want to replace general information with specific detailed steps. So perhaps you're using a commercial kit for a particular part of your protocol. Instead of saying the procedure was performed according to kit instructions, you want to actually describe how that procedure was done, because the kit could change, things could be adapted in the future. So you want to have good documentation about exactly how each phase was done. I mentioned that it's important to use active voice when writing your protocol. So what does this mean? When we're writing our protocol in active voice, we give clear instructions. So for example, we might say combine reagents in a 100 milliliter flask, instead of using the passive voice where we would say reagents were combined in a 100 milliliter flask. Again, we're directing the user of the protocol and how to do something. And so we want to do that in an active voice. The troubleshooting section is really important. This is a wonderful place to convey expert knowledge and to help save people who are using your protocol time. So you want to provide troubleshooting tips, and if you have identified common errors that tend to cause problems for people, you want to specify those. If you've identified things that do not work, you can also provide clear statements about this to prevent others from making the same mistakes and losing a lot of time. Readability is really important to consider. So you want to make sure that your protocol is easy for others to read. There are many ways you can do this, but here are a few examples. You might want to explain abbreviations or definitions. When you're working with abbreviations, it's always best to limit the number of abbreviations you use and to only use them for very common things. You also want to remember that an abbreviation can have very different meanings in different fields or in different contexts. So it's often helpful to Google the abbreviation that you're working with. And if the definition that you're using isn't one of the top 2 or 3 that shows up, you might want to avoid using that abbreviation. You may want to include photos or videos to illustrate complex steps. In some cases, it might be helpful to include drawings. I think all of this is really useful to help illustrate how to do something. And then you want to offer a graphical overview of the procedures if you can. And again, this can help quickly orient others to the protocol and have a sense of how to get things working and how the different steps fit together. Asking someone else to test your protocol will give you valuable feedback on how easy it is to reuse the protocol. You might ask them questions like, what isn't clear? Where did you get stuck? Or what mistakes did they make? What things didn't work for them? What information is missing? And have you captured all of the unwritten knowledge that is circulating amongst the people in your research group that use this technique? Getting feedback from your collaborators who use the protocol can be really helpful, as they will have a lot of unwritten knowledge about how to make this work best. And they may also help you with additional tips and tricks or things that did not work that they are aware of and that you haven't tried yet. Okay, so once we have our protocol written, we want to deposit it on a protocol repository. What should we consider when choosing a protocol repository? This will be covered in a little bit more detail in our video on depositing a protocol. However, there are 3 particularly important characteristics that I will ask you to keep in mind. The first 2 are that the protocol repository should offer versioning and forking. Versioning allows you to post an updated version of your own protocol as it evolves, whereas forking allows others to share adapted versions of your protocol to show how they're using it in their own research or in another context. Versioning and forking are very valuable features because they allow us to track the evolution of protocols both within and among research groups. And as the person depositing the protocol, forking is also really helpful for you because you can see how others are using and adapting your protocol and talk to people who may also be building on your methods. The next thing you want to look for is that the protocol has a long-term preservation strategy. So you want to make sure that your protocol will not disappear if the repository ceases to exist. Right now, Protocols.io is the only repository that we're aware of which currently meets all 3 of these criteria. We have asked the other protocol repositories to add features that they are missing, but due to the fact that Protocols.io is the only one that has these criteria that we know of, our protocol depositing video does focus on that repository. How do you deposit your protocol? I won't go into detail on this here, but I would encourage you to see our video on depositing protocols. What should you do after depositing your protocol in a public repository? There are a number of critical next steps that you might take. The first thing is to cite your protocol in publications, in grant applications, or when depositing datasets generated using that protocol on public repositories. And those citations help others to find your protocol, and they give others a very clear idea of how exactly you're implementing your methods in your research group. If you have a method in a protocol that's new, or that's a significant advance on a previously known methods, then you might consider publishing a lab protocols article in PLOS One. The benefit of this article format over others is that it combines the benefits of posting a living protocol on a repository with the benefits of having a peer-reviewed publication. So most protocol or methods article are static, which means as soon as you publish them, they can no longer be updated, and therefore they quickly become out of date, and they reflect what a single lab was doing at one point in time. The lab protocols article links to the dynamic version of the protocol, so it'll link to a specific version, but if users go to that protocol, they can also see if there are newer versions posted explaining how you have adapted the protocol in the time since the article was published. Finally, you want to keep your protocol up to date by posting new versions as the protocol and materials evolve, or as you adapt the protocol to new uses. And when you're citing your protocol, you always want to cite the correct version that you used for a particular study. So you may be wondering, if I deposit all my protocols, do I still need a methods section? And the answer to this is you always need a methods section. And we've talked about this in other videos, but just to remind you, all readers need information about an overview of your study design and the methods that you use to answer your research question, as well as information needed to assess scientific rigor, the risk of bias, and whether the methods you used were appropriate for that research question. And the methods section of the paper should always provide that information. A smaller number of readers will want details to reproduce the experiments. And while this is fewer readers, these readers are especially important because they are the people that will be following up on your research work and citing your research work. And as we've discussed before, putting this information in a protocol repository can be much more useful to others than offering a general text description in the method section of your paper. So as homework for this video, we suggest that you work on either writing a new protocol, perhaps for a procedure that isn't well, or that it hasn't been documented yet that you use in your research, or perhaps you have a protocol that's already partially documented, or maybe is documented well, but hasn't been updated in a while. And you might want to improve on that protocol and then deposit that protocol on a public repository. And it's up to you whether you choose to make your protocol public, but we would certainly encourage you to do that so that you can cite it and others can reuse and cite your protocol as well. And finally, if you're not sure where to begin, you might want to consider joining our Write and Publish My Protocol working group course to get started. And this is simply a group where we meet weekly and everyone works through their protocol repository writing and depositing process. And some people also work on preparing lab protocols articles for PLOS One. Everyone works at their own pace. Instructors are available to answer questions and to help you with things that you're working on or questions that you might have, and you can also share experiences or get feedback from other participants in the working group. So I'd like to thank everyone for watching this video today. We hope you found it helpful, and we look forward to seeing you more in a future video. Thanks again.